So to understand the new EIGRP, we need to first of all know whether this version will support it. Any operating system version above 12.4 show version. Let's see the version now. This is actually version 15. This will definitely support. So if you see now, show run section router EIGRP or earlier configuration, it is like this. I'm going to remove this. So EIGRP is gone now. No EIGRP now. If you want, you can check now. Nothing will come. You see? Nothing.
Yeah.
Show IP protocol. There is no EIGRP. Do you see EIGRP?
No.
Show IP EIGRP interface brief. EIGRP interfaces? No, nothing. No interface running EIGRP. But if you go to router 2, show IP EIGRP interface, you will see two interface. On router 2, let us have the old one, old method. I'm doing this purposefully to show that they are compatible. In router 2, I'm not going to remove this. What is the autonomous system number? That is important, 100.
Yeah,
Now I'm going to the other router. I'm going to say router EIGRP, and I'm going to give a name. I'm going to give a name as water. EIGRP, water. But usually what we used to type there? A number.
Number, yeah.
But now I'm not typing number. Is this an autonomous system number? No. It is same like a simple process ID. Just it is identifying EIGRP, that's all. It is not allocating this EIGRP to any autonomous system. But here, this allocates the EIGRP process to a number called 100. But here, nothing like that. But I tell you, whether it is newer method or old method, autonomous system number is mandatory. If it is mandatory, then where I am going to give the autonomous system number for the newer method, I'm going to give it inside. I'm going to give it inside.
Yeah.
How do we do that? We do that by typing address family, IPv4. So what I'm trying to say here is the autonomous system number of EIGRP that I'm going to give is not for IPv6, it is for IPv4.
IPv4. Yeah.
Autonomous system number 100. From this, you should have got an idea. What is an idea? What is that? What idea you should have got, or what you should have understand by now is under this EIGRP process, I can have IPv6 and IPv4. Whereas in here it is not like that. If you want to configure IPv6, there is a separate command. IPv6 router EIGRP 100. You understand? You need a separate configuration. Yeah. So this is separate EIGRP. This is another EIGRP. Two separate configuration. You can see the true run. You see, there's an IPv4 separately, IPv6 separately. Whereas in this, just under one EIGRP, I can have IPv4, and if I want, I can also have IPv6.
So this is a new type of EIGRP
The
configuration.
reason why
Okay.
they came up with the new type is so that you no need to have two separate configuration for 4 and 6.
Mm-hmm.
You got it? You no need to have a separate EIGRP. Now, if I type show run,
Understood.
you
Yeah.
see, it is only one EIGRP under which you have both IPv4 and
Mm.
IPv6.
Yeah. This looks very
Yeah,
neat, right? Like under one topology,
yeah.
all the configurations
Whereas here,
for
it
which
is not
version.
like that. This is separate. Again, this one
Yeah.
is separate.
Mm-hmm.
Fine. Now, let us go and enable for IPv4. I need to first say
Mm-hmm.
router EIGRP and a name. And then I need to say I'm doing this for
Mm-hmm.
IPv4. And then network as usual. 10 network
Mm-hmm.
and 192.168 one network.
Mm-hmm.
That's all. See, the neighbor has come.
Mm-hmm.
Now, if you
Okay.
check show IP EIGRP interfaces, you see two interfaces. And it belongs to autonomous system 100
Mm. Yeah.
and the
Mm-hmm.
virtual route instant of EIGRP is water. See, the output is slightly different. If you go to
Mm-hmm.
router 2 and check the same thing and show IP EIGRP interface, you see there is a big difference in the heading. See, this part is same. This
Yeah.
part is same for both.
Mm-hmm.
But see the above line.
Mm-hmm.
Above line is not same.
Mm. Yeah.
It is having something called
Same, not
address
same. Yeah.
family, water, which was not there in the previous.
Mm-hmm. Sir, one question here, like EIGRP we can configure for virtual
Yeah, why not?
interfaces as well, right?
This itself is a virtual
Now we,
interface, loopback.
Mhm. Yeah, yeah, correct.
Right, so you can see that the form neighbor show IP, IGRP neighbor. There is no problem in forming neighbor. You can have one router with the new method, one router with the old method. Doesn't matter. One big advantage is I can have both IPv4 and IPv6 on the same
Mm-hmm.
EIGRP instance.
EIGRP process. Mm.
Yep. Fine.
Mm-hmm. So I think NXOS we have this new model, right? I have seen this kind of configuration in N9K.
So this OSPF, which we have already seen in the introduction, let's have again quick brush up and then get into the new portion of OSPF. Open shortest path
Mm-hmm.
first is a link state routing protocol. Why do we call it as link state routing protocol? Because the
Yeah.
link state informations are advertised to every router. What is the advantage? Advantage is because you are advertising the link status, meaning information about all the links, the update receiving routers will come to know about the complete topology. Whereas in EIGRP or other routing protocols,
Mm-hmm.
other than link state routing protocol, all other protocols, they advertise only the best routes from the routing table. So when you advertise only the best
Mm-hmm.
routes, the neighbors will not get chance to know about the complete what? Topology.
Mm-hmm.
Complete topology.
Uh,
Complete
Complete routes.
routes for
Yeah, yeah,
all
routing table.
destinations.
Mm-hmm.
So it is always the link
Mm-hmm.
state routing protocol used in a large network and its service provider enterprises networks. Widely used routing protocol is OSPF because of its link state. They send that advertisement.
Mm-hmm.
Sometimes they send a tiny LSA. Sometimes they send a collection of LSA, which is called as LSU. LSU stands for link state update.
Mm-hmm.
Link state update is nothing but
Mm-hmm.
many LSs put together is LSU. And these LSUs are all
Understood.
collected into a database, which is a kind of topology table for OSPF. The database is called as OSPF database. You can also compare it to a topology table.
Mm-hmm.
Linked state database. Linked state database is nothing but the topology table of OSPF. Now, in that topology table of OSPF linked state database,
Mm-hmm.
the complete topology information is now gathered. At least within an area, the linked state database will be identical,
Mm-hmm. Mm-hmm.
because within an area, all router will advertise everything. But between areas, they don't advertise everything. Sometimes when you do summarization, they only send summary routes.
Mm-hmm. So within area, they won't advertise, but they will be using that centralized
No, not like no.
portion for right.
Within an area,
Traversing. Mm-hmm.
every router will say everything to all routers.
Mm-hmm. Mm-hmm.
Between areas, only relevant things will be sent. Only necessary. Say, for example, if I am in
Mm-hmm.
10th standard, I'll know only about 10th standard updates.
Mm-hmm.
I'll have very less information about 9th
Mm-hmm.
standard and 12th standard and 11th standard. Likewise, 11th
Mm-hmm.
standard people will have more information about 11th, less information about 10th and 12th. Because those informations are not shared. 11th
Mm-hmm.
standard informations are not shared to 10th standard students. But they do share something which is common for
Mm-hmm.
all standards. Likewise, OSPF also
Yeah.
don't share everything to other area, but within area they share everything. Every update is shared within area. But between areas, few updates are filtered. What are those few updates? We learn that later when we go to a topic called LSA types, linked state advertisement types.
Mm-hmm.
Sir, we have a lot of newspapers.
Mm-hmm.
Some newspapers are local.
Mm.
They will have more information about
Yeah.
local. They will even say
Mm-hmm.
in that shop the tomato price is very less today compared to other shops. But you will
Mm-hmm.
not have such information if
Mm-hmm.
you take newspaper from the other state.
Mm-hmm.
So some newspapers are local. They will have less information about the other state, but more information about the local. You will also have some national
Mm-hmm.
newspaper where you have more information about all the states of India,
Mm-hmm.
but less information about international news. Likewise. Advertisement also in
Mm-hmm.
OSPF, some are local advertisement, some
Yeah.
are global advertisement. So these local advertisements will not be sent to global.
Mm-hmm.
As a result, the tomato price of Kerala will not be known to Tamil Nadu
Mm-hmm.
because it's tomato, it's local.
Mm. Yeah.
Likewise, within an area, you will
Mm-hmm.
have identical map because everything is shared to everyone in that same area. Nothing filtered,
Mm-hmm.
right? Without filtering, it
Mm-hmm.
shares. Okay. Now, on top of this database, The shortest path first algorithm will run and find the best shortest path for each destination and take that best path, put it into the routing table. So this entire chapter that we are seeing today is about this story that I just said. It's the same story I'm going to repeat in a detailed manner.
Yeah.
EIGRP maintains 3 tables. Neighbor table will have the neighbor information with which the neighbor is established, the interface through which the neighbor is connected, what is the router ID of the neighbor, and so on. Topology table, as I already said,
Sir, 1 second, sir. Like router ID is
that's a good
we can
question
give
which is coming later,
any
but I want to tell
interface
you the
IP
answer
address or
now.
like any loopback interface IP address.
Router ID can be any address, even the address that is not on the router. It need not to be there on the loopback. It need not to be there on the physical. It need not to be there on any router on this earth, on your office. Router ID is simply a name given in an IP format to identify the router. That address need not to be a pingable address. That address need not to be there on any interface.
Okay.
But if you don't give router ID,
Got it.
it is going to search for router ID on the loopback interface. If you will have more than one loopback interface, it will copy the big IP address from that loopback interface. Now, if you don't have loopback interface, it is going to pick the big IP address from the physical interface. So, first preference is given to manual configuration of router ID.
Got it.
When you configure manually, it will not go and pick one address from any interface. And when you give any address manually, that address need not to be there on any interface, neither on loopback nor on physical. I want to repeat this very clearly. That address that you are manually configuring as a router ID doesn't need to be there on any interface on this router or any router. If you want to give the same address that is there on the interface, that is also okay. But what I'm saying is, don't think that if I need to use one address that need to be a part of router. That need not to be a part of a interface. Not necessary. You should give the router ID unique at least within an area.
And this router ID will be a unique ID, right?
It is good to maintain unique router ID throughout the enterprises.
Yeah.
If you say, no, in my office, some part of my network is taken care by me, some other part are taken care by other engineer. In that case, how you will know what router ID he has given? So that is okay. But see, because he is another administrator, definitely he will be in another area. You are in one area, he is in another area, OSPF area. We saw in the previous class, OSPF is divided into multiple areas. Within an area, your router ID must be unique. Try to maintain unique router ID throughout your autonomous system, throughout your office. But if not possible, at least within your area, it should be unique. Within area, let's say you are 10th standard guy. There's a student called Arun. Within the area, within that class, there should be only one Arun. Otherwise, it will be confusion. In two different class, If Arun is there, no problem. This is 10th standard Arun, that is 11th standard Arun. No problem. But within 10th standard, if we have two Arun, then
Correct.
only conflict. Same way. Within an area, the router ID needs to be identical. Sorry, unique. It should be unique. It should not be identical with anyone. It should be unique. Okay? So that's about the router ID of a neighbor. See, in the neighbor
Yeah,
table,
correct.
it will not show you the IP address of the neighbor. It will show you the router ID of the neighbor. What does that mean? Say, for example, I'm taking thing to router. Now, let's say this is my loopback interface 1.1.1.1. This is my loopback interface 2.2.2.2. And this is my physical interface 10.0.0.1, 10.0.0.2. When we don't configure router ID, router 1's router ID will be 1.1.1.1. So according to router 2, who is the neighbor? 1.1.1.1. It will not show 10.0.0.1 as a neighbor. It will show the router ID of the neighbor in the neighbor table. It will say 1.1.1.1 is connected via G0.
Yeah.
And router 1 will say 2.2.2.2 is connected via E1. This is what you will see in the neighbor table.
But if it okay,
You
yeah.
understood? So neighbor table will show only the router ID. Now, what
Yeah.
if I don't have? I don't want loopback address. Then I can manually configure router ID. Anything. It need not to be 111. I can say 7.7.7.7. Manually, I'm configuring. And for router 2, I'm configuring 9.9.9.9. So these are all router IDs manually configured. Are they in any interface? No.
Yeah.
This 9.9.9.9 and 7.7 is not in any of the router interface, but it can be used as a router ID. So according to router 2, what is the neighbor address? How it is identified?
No.
7 dot via G0. Don't go and try pinging that address. It won't ping, but you will find that as a neighbor. 7777 is not pingable address, but
7.
that's just a name in an IP format given to the router. That's just a name in an IP format given to the router. So that's the neighbor table. Neighbor table will have the list of established neighbors. And the neighbors are identified with the router IDs. The topology table, as we already spoke, it has got a collection of LSAs and LSUs. It has got all possible paths along with the cost to reach every destination. Now, within an area, this topology table will be identical. Routing table, as usual, will have only the best routes for every destination. And the routing table is also called a forwarding database because based on this, only the packets are going to get forwarded. Why linked routing protocol? We already spoke this because you got the complete topology. When a path fails, you can immediately swap to the alternate path. Very fast convergence, isn't it? Not only that, because you got the complete topology, you can make accurate path selection. If someone gives you
Mm-hmm.
every street
Yes.
information in the map, you can take best path. If someone gives just overall
Mm.
main road only, main road in the map, then you may not take accurate path for all destination. Sometimes going in the main road is a
Mm-hmm.
long
Yeah.
distance. If you are
Mm-hmm.
going by car or bike, you can use main road. Well, I want to go by walk. Well, then if I
Mm-hmm.
use that main road map, then I'm going to walk for long distance and for long time.
Mm-hmm.
Climbing a mountain will take 2 hours. If you go
Mm-hmm. Yeah.
not tunnel, not climbing to the top of the mountain, if you go through the rocks and bushes,
Mm-hmm.
you can easily climb in 2 hours. But if you
Mm.
go through the road, it is 14 kilometers. It will take the
Via tunnel
whole
then.
day. The road is zigzag, isn't it?
Mm-hmm.
The mountain roads are zigzag.
Mm.
It will take a long time. But if you simply keep walking,
Mm.
climbing over the stone, one stone over the other, you can easily climb a mountain.
Mm-hmm.
I have not climbed a mountain
Mm.
through
Yeah.
the rocks, but I have climbed through the jeep.
Yes. Yes.
Last week also I was driving 14 kilometers via the road to go to the top of the mountain. But people
Mm-hmm.
say if you come by walk, it is only 3 kilometers. The height of the
Mm-hmm.
mountain is only 3 kilometers. So if you have a complete picture,
Mm-hmm.
then you can take accurate shortest path. That's why we need link-state
Yeah.
routing protocol because they give the complete picture.
Yes. Yes.
Now OSPF follows the hierarchical design, the
Mm-hmm.
the backbone area and the non-backbone area. Every non-backbone area must be connected to a backbone
Mm.
area in order to communicate each other. If if area 1 wants to
Mm-hmm.
share some routes to area 2, without area 0 it is not possible. That is how OSPF is designed.
Yes.
For that, in an area you should have at least one ABR router. What is an area border router? ABR router.
Mm-hmm.
What is the area border router? That
Mm-hmm.
CDE, they are ABR routers because one link is connected to area
Mm-hmm.
0 and the other link is connected to their local area. So if
Mm.
you should have at least one routers, one link to area 0.
Yeah.
So
Correct.
if you don't have ABR, then you cannot share routes to other area. You need an
Mm-hmm.
ABR, at least one ABR for area in order to share the routes to area 0 so that area 0 can share it to area 2.
Mm-hmm.
Area 1 cannot directly share the routes to area 2. Any area, if they want to share routes to other area, they have to give it to area 0. Area 0 only can give it to them.
Mm-hmm.
Like if you go to orphanages, you cannot give directly food or a gift to the children in orphanage. You
Mm-hmm.
have to give it to the management. They are area 0. Without going through management, you cannot go even talk to the orphanage children. They don't allow us to talk. No children in the orphanage should talk. They have put very strict rule to all the children. If they talk, they will be punished. Even if we go and talk, no, they will not talk.
Mm-hmm.
So it
Mm-hmm.
is only through the management. If you want to give food, you should want to give
Mm-hmm.
cloth, it should be given to them. Only if they want, they will give
Mm-hmm.
to the children. If they
Mm-hmm.
don't, if they say no, we don't want you to give, we cannot give.
Mm-hmm.
Some orphanages, they don't take food nowadays. Sorry, you give us money. We don't want food. Fine. So now you see, these areas are important. Otherwise, all the routers will be in one big area and it will be difficult to manage, as you said in the previous class. It will be difficult to manage because all the routers will have all network link information and the database will be too big. To minimize the size of the database and the routing table, we have many areas and each area will have detailed information of the local network and the summary information of other area networks. In that way, you can minimize the size of the routing table. So to do summarization, we do that in ABR. See, if you don't have many areas, you will not have summarization point. Because you have multiple areas, you got C, D, and E. That is a summarization point. If you don't have areas, where will you summarize? EIGRP is useless. You can do summarization anywhere. That's not proper approach. There is no proper approach. Here you see they have a very nice approach. You want to do summarization, you do it in the border.
Correct.
Fine. So in EIGRP, autonomous system number is the only one that groups the routers. In OSPF, there is no autonomous system number, area IDs. And all area with one single area 0 in the middle together called as autonomous system. What is the autonomous system number for this OSPF? No autonomous system number. We don't identify with that number. We see whether these areas are all connected to one area 0. If yes, then they're all one autonomous system. So because of this area concept, if any change in one area, that is not going to impact the other area members. The impact will be only local to that area. That's a very good thing. As I was telling the other day, if there is a big flood in Kerala, everyone in Kerala will be worried. But if you see at the other side of India, they will be celebrating some festival. They don't care. Why they don't care? If you start worrying, then you have to worry every 365 days. Because when country is big, every day some sad thing will be going on in every corner. Then no one will be enjoying their life. Because there are many states, at least north enjoying when we are suffering. It's okay. At least there, let them be happy. Likewise, when they are sad, we don't worry. We enjoy Onam. We enjoy Diwali. When there is a big earthquake in Delhi, we don't see. If you start worrying, then you will become sick and will die soon. You cannot keep worrying for every small thing that happens in one corner. So it is good that we are in different states, so that the impact is localized. Not everyone become psychologically weak, and that's not healthy living. Instead of worrying, even though we celebrate Onam, we send some relief. We send some money. We send some helping aid. Though we are celebrating, we parallelly we support those people who are suffering there in the north because of earthquake. It doesn't mean that we are not taking care. We take care of them, but we don't simply worry like what they are worrying, because they are seeing it through the eyes. They worry. We support them so that they will come out of it. Okay. Now, It is good that we have areas. Otherwise, every small change will impact every area. Not good. Every router. So we have ABR, we have backbone router. A and B are backbone routers. CDE is ABR router. What about F, G, and H? They are non-backbone routers. They are internal to non-backbone areas. OSPF send a hello packet every 5 seconds
APR out.
in a LAN environment.
They are within areas. So.
Every 5 seconds
Yeah,
in a
non-backbone,
LAN
yeah.
environment. So in LAN, hello and dead timer. In WAN, NBMA network, it is different. In LAN, hello is sent every 10 seconds. Not 5, sorry, it's 10 seconds. EIGRP only 5 seconds. And the dead timer is 40 seconds. Whereas in WAN, the hellos are sent every 30 seconds. 4 times of hello. See, 4 times of hello is 40 here. 4 times of this one will be 120, isn't it? So that is WAN timer in OSPF. WAN is also called as NBMA network here. NBMA stands for non-broadcast multi-access, which we will be covering in coming chapters. So the timers are different, but the hello packets are same.
120. Yeah.
Hello packets are going to carry certain parameters. And those parameters in detail is coming in the next chapter. So to form neighbor, the parameters, some parameters should match. Say for example, you are going to a new country. Yeah, okay, I am going to a new country with my family. What parameter I will see in order to form neighbor? First, I will see whether that family has got a decent outlook. That's the first thing I'll see. Are they having decent outlook? To see, are they looking decent? First thing I'll see. Second thing, what I'll no.
Okay. Sir, hello, sir. Actually, some interruption. Like, 1 second, sir. Around